Hello everyone. So today I will be teaching you about the definition of functions, relations, and how to evaluate functions. So a function is a set of ordered pairs x, y in which no two distinct ordered pairs have the same first number. Think of function as some sort of a machine which when you give an input, you will be given an output. So for example, in this diagram, you have an input of 3 and our output will be 11. Input of -7, and an output of 1, and then 10 to 4, and then 13 to 6. To better understand this, we can also write it in many ways. For example, we can write it in ordered pair. The first example, we can write this as 3, 11, -7, 1, 10, 4, 13, 6, where the first number is the input and the second number are the outputs. Also, we can write this in table form. So these are the x values or the first numbers. We can x is also the first number or the input, and y's are just the second number or the output. Okay, so another example is this. We have an input of 1 and an output of -5, 2, -5, 4, -5, -2, and 6. Even though they have similar outputs, it's still a function because the definition of function states that no two distinct ordered pairs have the same first number. Even though they have the same second number, they still have different first number. So this is still an input. Other ways to write functions is of equation form. This is a type of function where x is the input and f of x is the output. For example, f of x is equal to 2x plus 1, f of x is equal to square root of x, f of x is equal to x squared, f of x is equal to 1 over x plus 2. All of these are functions. Okay, so an example of not a function is this. An input of 0 to 0, 1 to -1, 4 to 2, and 1 to 1. We can see that you have an input of 1 and an output of -1 and an input of 1 and an output of 1 too. Okay, so we can see that we have two distinct ordered pairs, but we have the same first number. We can see that 1 has an output of -1 and 1, which means this isn't a function, and we can call this as a relation, because a relation is any set of ordered pairs with no other conditions. So just find an input and output, it's already a relation. So with that definition, we can say that all functions are relations, but not all relations are functions. You can think of functions as just relations, but with a condition, which that no two distinct ordered pairs have the same first number. Okay, we can see in this ordered pair that we have two distinct ordered pairs, but we have the same first number. This is just the previous example. So this isn't a function. Okay, so let's add the definition more. So the set of all admissible values of x is called the domain of the function, and the set of all resulting values of y is called the range of the function. It's just saying that all possible values of x is what we call the domain, and all resulting values of y using the domain or the values of x is the range. For example, we have an input of 3, -7, 10, and 13. So all admissible values or all possible values of x are just -7, 3, 10, 13. We can write it as d or domain is equal to x such that x is equal to -7, 3, 10, 13. It's best if we can write it as in ascending form so it can be proper. And the set of all resulting values, which means the domain of x, when we use the domain of x, we have this result, and the results are the range. So we can see that the output gives an answer of 1, 4, 6, and 11. So we can write the range as y such that y is equal to 1, 4, 6, 11. Okay, now let's um, evaluate functions. So to evaluate functions, it's just very simple. So we are given a function f of x is equal to 2x plus 1. f of x, meaning x means that the equation has a variable of x. So we have 2x plus 1. And then in A, it says find f of 2, meaning you replace x with 2. That's just how you evaluate functions. So we have f of x is equal to 2x plus 1. Find f of 2. So to find f of 2, it's just f of 2 is just equal to 2, and our x, it will become 2 now. 2 times 2 plus 1, which is just equal to 4 plus 1, or 5. And that's the answer for A. Okay, so I'll give you time to answer B and B to D. It's just the same process. Okay, now let's solve B, f of 0. So it's just the same process as earlier. So we solve f of 0 is just equal to 2 times 0 plus 1. So 2 times 0 is obviously 0, and plus 1. So the answer is 1. Okay, now let's solve for f of 3 over 2. So all the same process. 2 plus 1. Okay, so 2 times 3 is equal to 6. Divide by 2, it's just 3. Or we can just cancel here. So 3 plus 1, so the answer is 4. And lastly, f of negative 2. So for f of negative 2, still the same. Just have to substitute the number to the excess here in this equation. 2 plus 1. Okay, so 2 times negative 2 is negative 4 plus 1. So the answer is negative 3. I hope this is very clear to you guys. Okay, now let's talk about a different type of function. This is what we call a piecewise function. It, the difference is that we just have different functions for values of x. For example, when we have x is less than 0, meaning it could be negative 1, negative 5, negative 4, the function that we will be using is 10 over x. Okay? Now, when x is equal to 0, the function we will use is 4. And lastly, when x is greater than 0, the function we will follow is square root of x plus 1. Okay, let's solve some problems here so we can better understand. So f of negative 5, so f of negative 5 falls in x less than 0 because our x will be negative 5 and negative 5 is less than 0. So what we'll use is 10 over x. So x will become negative 5. So 10 divided by negative 5 will be negative 2. Just like that. Okay, now let's solve f of 9. So 9 is greater than 0. So what we will use is this function. Okay, so it will be square root of, it is square root of x, but since we have 9, so we'll use 9. 9 is our input. Okay, so square root of 9 plus 1 is equal to, square root of 9 is 3 plus 1. The answer is 4. Okay, now what we need to find is f of 0. Okay, so 0 is just equal to 0. And we just have to use this since our x is equal to 0 here. So when x is equal to 0, our function is 4. So automatically our answer is 4. It's just that simple. Okay, so last is f of negative 10 is equal to 10 over negative 10. We will follow this because negative 10 is less than 0. So the answer is negative 1. For me, the trick you can do here is that you can draw a number line. So let's draw a number line here. Oops, let's draw it really. Number line here. And we know, and we have number here 0. Okay, so it says when x is less than 0, so we have x is less than 0. What we will use is 10 over x. When x is equal to 0, we will use 4. And when x is greater than 0, we will use square root of x plus 1. For me, this is an easy way to not get confused using piecewise, and then it's just easy from here. For example, when it is negative 5, so in the number line, let's say it's somewhere negative 5, so it's somewhere here. So it falls within this yellow, so we will use this. And that goes the same for other. So when it is 9, so it is somewhere like here, 9. So we will use this. And then when it's 0, we will use this 4. And then when it's negative 10, it's like here, we will use this again. So that's how you evaluate functions. And I hope you learned about definition of functions, relations, and how to evaluate it. Thank you.